We move to the next session that will give you an overview of our results about advancing phenotyping capabilities of the SmartCow consortium. And the first presentation in this session will be given by Chris Reynolds.
Thank you, Rene. Good morning, everyone. So I'm the work package leader for work package 5, which focused on evaluation and standardization of nutrient use efficiency and emission measurement techniques. And the aim of the work package was to identify and attempt to address sources of variation and what we considered key in vivo measurements of dietary nutrient use efficiency and emissions of methane and nitrogen by cattle. And we're really talking about feed digestion and nitrogen balance measurements and methane emission measurements, with a focus for our methane emission measurements on respiration chamber measurements. And our key concerns were the precision and the accuracy of these measurements, the sources of variation in them, in other words, and also the impacts of these measurements on animal welfare. These measurements are not new measurements. Scientists have been using these techniques for over 100 years to measure digestibility and methane emission. And our concern going into the project was because these are old measurements that people have perhaps become blasé and perhaps not careless, but not as careful as they should be in using the measurements, and that therefore resulted in variation. So what we wanted to do was to assemble the results of the project and look at variation associated with location, where those measurements were being made, and then whether or not those differences due to location were due to methodology. And in addressing this measurement error, we wanted to increase the precision of the measurements, or refine, thinking about the 3 R's, and also to reduce the requirements for animals in designing our experiments. And I think Kenny's going to refer to this more in his presentation. So one of the things we did was we assembled a very large database of nitrogen balance measurements, digestion and nitrogen balance measurements, both from within the SmartCow infrastructure, from previous experiments that have been conducted, but also through collaboration with the Joint Research Alliance and specifically the Feed and Nutrition Network. So we conducted a meta-analysis of this data, and you can see in the graph on the left, this is showing measured nitrogen balance relative to nitrogen intake. And the slopes presented are the relationship for each individual location. And you can see quite substantial variation there. This is also shown for the relationship between nitrogen intake and fecal nitrogen excretion, and also urinary nitrogen excretion. So in looking at the sources of variation, we were wanting to look at specific methodology being used, but one of the things we found was that there was confounding, between site and methodology, because at many of the sites they only use one methodology. So it was really hard to disentangle methodology from site. But we can see that, of course, the type of experiment being conducted, and this is associated with specific aspects of dietary intervention, accounted for a very large percentage of the variation in these data. But site also had a significant effect as well. When we drilled down into the individual methodology, then the specific methods being used didn't have as much of an impact as we thought. And we think that in part this represents the fact that it's not the methods per se, but it's how the methods are being used. In other words, it's human behavior. And this gets down into training of the staff and the commitment of the staff in terms of the care with which they're conducting these measurements. And we kept coming back to that in our meetings and our discussions, and the importance of training. Another aspect of the activity was that many of us worked on our facilities and our equipment that were being used and our techniques. And at UREAD, they put a lot of time and effort into developing some new digestion stalls that were able to be used for different size animals. They're very adjustable. And these are much better for the animals, but they're also much better for the people that are conducting the research. So it's better for the welfare of the animals. It's better for the safety and the welfare of our staff. And so I know NRAE are very pleased with these stalls. And at the University of Reading, we also completely renovated our digestion equipment. Our original stalls that we were using and our respiration chambers were designed when our cows weighed about 500 kilograms. In our commercial dairy farm now, our cows weigh between 750 and 800 kilograms now on average. They're just much bigger. And so we needed larger equipment. We needed adjustable equipment to account for different size animals to make it safer for them to be used. And so these stalls, they can be opened up when we're not working with the animals, and then we can restrain the animals in the stalls when we want to take samples or milk them or do something else. So again, they're much better for the welfare of the animals and also the staff. And one thing I wanted to highlight, and I think Kenny may mention this as well, is that we adopted the use of waterbeds in our digestion stalls. And this just made a very noticeable difference in the comfort of our cows. And when we adopted these waterbeds, when we put our lactating cows in our respiration chambers, the stability of their intakes, the stability of their milk yields was much improved. The other thing is that at all locations, I think we worked on improvements in our urine and fecal collection equipment. Some of us have adapted at a number of locations a vacuum collection system using funnels, gravity-filled funnels that are then vacuum evacuated for collecting urine from steers or from male cattle. And we worked quite extensively on urine collection cups and equipments that's more welfare friendly for collecting urine from our cows. And these all made improvements in our measurements. One of the purposes of our work package was for all of the participants at the different installations in SmartCow to individually look at no matter how we were approaching our digestion measurements, whatever equipment and techniques we were using, we wanted to address the sources of variation that we knew were contributing to variation in our measurements. And these were evaluated through very critical evaluation at each installation. Some of us looked at days of sampling and the impact of that on variation, and that was done at NRAE and the University of Reading. A number of us looked at volatile nitrogen losses during our sample collection and analysis, and there was some good data from Wageningen and from FBN in Germany. For example, and Wageningen found that they had higher nitrogen intakes measured when they used Dumas instead of Keldal analysis. And so people assume that a lot of our variation in our measurements is due to fecal and urine collection and analysis, when actually a lot of the variation comes from our measurement of intake, which is something extremely simple to do, but has to be done very careful. And associated with that is how we sample and analyze our feed for nitrogen concentration. And so we went back and looked at that again very carefully. And a number of us then measured or addressed volatile nitrogen losses, especially ammonia, from our samples during collection and analysis. Some of us used markers for estimating digestibility through fecal sampling, and Aarhus University did a lot of work looking at their markers, their fecal sampling technique in terms of how many spot samples over how long a time period to get the best estimates of digestibility. And then in January of this year, we held a workshop. We all got together. We reviewed our results and discussed them and agreed key factors going forward. But we keep coming back to this attention to detail, training of staff, and the commitment of our staff and our students that are conducting these measurements. So just some examples of some of the results. On the left, we can see that crude protein concentration of diets fed at FBN were lower when the samples were dried at 60 degrees compared to being analyzed fresh, where they were frozen and then chopped and ground in dry ice before analysis. And so you can see the effect of drying on nitrogen concentration. We've known this for years and years, but it's something that people just aren't addressing in many of their measurements. And then FBN also measured volatile nitrogen losses from their chambers when they weren't separating feces and urine, and they had up to 7 grams of nitrogen being volatilized from their respiration chambers. And this needs to be accounted for in our measurements if we're going to get a more precise estimate of nitrogen balance. At NRAE, they conducted a study where they measured digestibility and nitrogen balance of growing beef bulls at over 2 periods. And then they looked at the repeatability of those measurements and the precision of those measurements and accuracy, depending on how long they conducted their digestion measurements for. And as you can see in this figure, both for dry matter digestibility and for nitrogen balance, the repeatability of those measurements increases, especially once we get past 7 days of measurement. And the repeatability was highest at 10 days of measurement, suggesting that if we go to shorter periods, many people are using 4-day periods now because they don't want to have to pay people to work over the weekend. They can start a trial on Monday and finish it on Friday, and it's a 4-day measurement. But the repeatability of those measurements, this data shows, is just not as high. And so you need more animals in your trial if you're going to measure a significant difference. And that's illustrated by this data from that same trial, looking at dry matter digestibility and nitrogen balance. And on the left the x-axis is length of measurement in days. And on the left is the minimum detectable difference for dry matter digestibility. And you can see if we're just phenotyping, if we just have one animal, then the minimal detectable difference, is much higher. If we're comparing treatments, then the minimum detectable difference is shown for increasing number of animals up to 16 animals. And you can see the minimal detectable difference gets much smaller and is reduced when you have more animals, of course, but it also reduces as you increase the length of the measurement period. And for nitrogen balance on the right, you can see you can detect a 20% difference in nitrogen balance with 16 animals at 10 days of measurements. And this is just showing the benefit of having longer digestibility trials. So some of the conclusions, obviously I've mentioned this a number of times, strict attention to detail and protocols are absolutely critical to success. In terms of specific procedures, we've looked at numbers of days of collection. We looked at this at Reading as well with our lactating dairy cows. But in our studies, we had very similar estimates and measured very similar differences, came to the same conclusions with shorter periods compared to longer periods. But we had acclimated our cows extremely well before they went into the chambers. Their intakes were very stable. There were no differences from day to day in nitrogen concentration of the feeds we provided the animals. So with those very stable intakes, we were able to use shorter measurement periods. So variation in intake is a key factor in this. But with the type of trials that were conducted at NRAE, 7 to 10 days of measurement were required. In terms of feed and fecal handling, we, in our work at Reading, went to immediate analysis. So as soon as we collected the samples, we analyzed those fresh samples for nitrogen concentration without freezing them or anything. And this was what we considered our gold standard. For feed and feces, we found we could still freeze composite samples and get comparable results, but the samples need to be handled very carefully. We tried some fecal preservatives to see if that would help with reducing nitrogen losses, and it wasn't successful. Those data will be published. But it's also very important to account for these losses of ammonia coming from our measurements of digestion if we want a true estimate of nitrogen balance. In terms of urine handling, of course, we've known for years and years that acidification of urine is very important, and also mixing of the urine with the acid. But one thing we did find in our studies at Reading was that when we compared analysis of fresh urine that had never been frozen with frozen urine that was then thawed and analyzed, the urine nitrogen concentration was significantly lower. And this was recently identified in a publication that came out a couple of years ago from Ohio State University. And they actually showed that the time that the urine spent in the freezer increased the reduction in nitrogen. And so we need to address this going forward, and I think it's surprised a lot of people. I'm sure our predecessors 50 years ago probably could have told us that that was the case, but no, everybody's just forgotten about it. And then finally, sample handling. If we need to chop or grind our samples, we need to do that very carefully, and ideally we need to avoid drying. So finally, just a short few conclusions about methane emission measurements. We've conducted a similar meta-analysis of methane measurements from respiration chambers. And here what we found was that most of the variation was due to the experiments that were being conducted, and that was associated with diet composition and interventions, that perhaps additives, things like that. So much less of the variation was due to site, because everybody's using the same techniques primarily, and so there was less variation. We also, as part of the consortium, conducted a ring test of methane recoveries in our respiration chambers. And this was conducted by National Physical Laboratories. They conducted a similar ring test of respiration chamber facilities in the UK about 10 years ago. And so they conducted a similar test for our SmartCow consortium. And they very precisely released measured amounts of methane at different points in our methane emission measurement facilities, and looked at the efficiencies of recovery and helped us look at reasons why our recoveries might be different. For example, flow estimates and potential leaks in our systems. And this was really helpful for the consortium. These are the resulting chamber efficiencies. These haven't been published yet, but they show that across the SmartCow infrastructures, the individual chamber recoveries were really good. We only had a few instances where a chamber was outside a variance of plus or minus 3%, so 97 to 103%. They did help us at different locations identify problems in terms of things like leaks and flow calibration, so greatly improved the precision of our measurements within the consortium. And the comparability of our measurements was shown to be really good, especially compared to the previous ring test they conducted in the UK, where the comparability was much lower. But in that case, we had different types of chambers. Some of them were for sheep and some for cattle. But for the SmartCow consortium, the results look really good. So what are the implications of all this? I think we've identified sources of variation at each of our installations, and they've been evaluated and addressed in most cases. These standard methods can be approved, but through self-assessment and very critical evaluation. Human behavior is absolutely critical. It's not necessarily the specific method, but it's how the method's used. And so we think training and engagement of research staff, and in particularly students, is really important in achieving better measurements. Cow comfort and acclimation of animals to the equipment that's being used is critical. Again, everybody knows this, but we really need to focus on it. And also just accurate measurement of intake and diet compositions, absolutely critical. In terms of chamber measurements, recovery tests for SmartCow show really good comparability across our installations. This is for respiration chambers. It doesn't deal with other approaches like SF6 or using green feed. And we've identified some potential sources of variation. And I think these improvements that we've achieved within SmartCow are an exemplar for other researchers, and hopefully we'll provide an example for other people to follow across amongst our collaborators. So future prospects, there's still some questions we need to address. I'm sure, again, these are old questions, but effects of freezing on urine nitrogen concentration, I'm still surprised by this, and it's something we need to address. And we need to look at how we're measuring nitrogen concentrations of feeds as well. We've been sharing best practice, and I think we need to continue to do so. We've talked about staff training and workshops and perhaps study visit for some of our staff, and we're hoping that we can do this within the ERG. And we need to continue to think about alternatives, and that's what Cecile will be addressing next in terms of biomarkers and proxies, and that applies to our methane measurements as well. We'd also are proposing to establish a user group for methane measurements, and hopefully we'll be able to conduct future ring tests that will help us to validate our individual recovery tests that we're doing as a more routine practice at each of our installations. So with that, I'll say thank you very much for your time and attention, and I'll be happy to answer any questions.
So thank you very much, Chris, for this very interesting talk and large overview of all activities in WP5. I'm sure there are many questions. Yep.
Thank you, Chris. For the minimum detectable difference that you mentioned, if you have to measure longer, perhaps ethical committees won't like that too much, because you have to. The ethical committees don't like it too much because you have to keep the animals longer in the metabolism crate. If you do it shorter, you need more animals. So where's the trade-off? Is there any recommendation to make? Is it preferably to have shorter measurement periods with more animals or longer periods?
It's a really good question. I mean, I think if we can address our variation, then hopefully we can. And I think our trial at Reynolds showed that, and we're still analyzing the data, and we want to compare it to the growing bull data and look at differences. But with our cows, the intakes were so stable and their production was so stable that we could get away with a shorter period, okay? So I think it's going to depend on the type of animal, the type of diet, how well they've acclimated to the stalls, and the impact of being put in in our case, in a respiration chamber, in a digestion stall. And when that has more impact, I think we're going to need either longer periods or or more animals, sorry. And so that's a really interesting question. I might, I don't know if Kenny has any thoughts on that, but I think probably going for longer and having fewer animals would be the option I would opt for.
Yeah, so just to add to what Chris has said, I mean, I think there's two things. One, that trade-off may or may not be in place, depending on the goals of the study. So actually we already accept when we do power calculations in terms of thinking about animal numbers that comes with a certain effect size capability to detect. So actually I think what's really important is that we're aware of that effect that Chris has talked about and showed in those graphs, and we may under some circumstances be willing to accept a lower detection capability, because that's already what we do when we make decisions about animal numbers and effect sizes and power calculations.
But we should also be aware of the effect of length of collection period on our variance before we ever do the power calculation. Yeah.
I think one important aspect maybe Chris didn't mention, in the UREAD trial we were in ad libitum intake, so with some variation. I don't know for the other trial if it's the same. There was a question by Sven. Oh. No, first.
Okay, so I was impressed by the waterbeds that you presented on cows. Do you use those waterbeds in the digestibility stalls or only in cubicles? Because I didn't see on the picture.
Currently only in our digestion stalls.
Okay.
Currently only in our digestion stalls.
The two pictures were not...
no, that's right. I didn't have a picture. Well, in our digestion stalls, it just looks like another a rubber mat. It's hard to tell that it's actually a waterbed until you stand on it and it moves. But I can tell you our cows absolutely love them. They really do.
Yeah, thanks. Sven Däniker from Germany. Coming back to the lengths of this balance experiments, it's quite interesting and an important finding, the negative relationship between the lengths of the trials and the number of animals required for a certain probability or significance probability. However, we have to take into consideration that it is more and more difficult to get permission to prolong experiments longer than 5 days, because this is regarded as most serious for the animals from an animal welfare point of view. And so far, the results are very valuable for argumentation or for discussion with the authorities. Because on the one hand, they don't like to have the animals longer than 5 days in the cages. And on the other hand, they also wouldn't like to have too many animals involved. So this is a contradiction, needs to be discussed in the future. Thanks.
Thank you for your comment. It's very important. I would add that as part of the trial at UREAD, they also looked at hair cortisol concentrations and got some really useful results in terms of stress of animals when they went into the digestion stalls. I didn't include any of that. I think it would be valuable to be able to measure the effects of length of duration in the stalls on the stress levels of the animal. So.
Yes, we will present this result at the EAP conference in Porto. Jean-Louis, for a last question.
Okay, Chris. Did you try to correct the data on nitrogen balance with the mean temperature during the measurement. Because in rain, we observe that to some extent, we can have some urea losses with sweat in dairy cows. And we have much higher nitrogen balance, so no recovered nitrogen in summer than in winter, in our diet.
Sorry, I didn't...
Sweat.
With sweat.
Oh, no, none of us, I'm aware of work looking at sweat. I'm aware that you guys did it. But, no, we did not address sweat. I know it can add up. It's normally a small loss, but it can add up to quite substantial when animals are heat stressed. Yeah. No, it's not. It's something else that needs to be added. It's one of those other things we don't measure that affects, our nitrogen balance calculated by difference. Yeah, absolutely. There are others we couldn't address as well, but yeah.
So,
it's a good question.
So thank you.
Thank you, Jean.
There is a comment in the chat. Many thanks for your presentation. You spoke about the creation of user groups for sharing on tools and methods inside SmartCow consortium or larger, which links with ICAR groups. This is probably a general question, but what I can say, we have some contacts with ICAR. ICAR belongs to the stakeholder platform, but of course, through the book of method and the outcome of our project, we are very interested to develop more relationship with ICAR, and we can organize a meeting for that. Okay, and surely British cow do not sweat.
They do now. Heat stress is becoming much more of a problem in Britain than it was 20 years ago.